Good morning to all. Myself Badi Alekhya, Assistant Professor AIML Department, RMD Engineering College. Today we are going to discuss about the importance of performance matrix to calculate the accuracy of an given model and what are the terminologies to find out the performance of the given model. Let us discuss in the upcoming slides. So first of all, we know in which type of problems we are following these different performance metrics. So under classification models, if you want to categorize any class of data identified based on your training, how you are going to group your classified data into new classes or groups, and how we are going to evaluate the performance of the classification model by using some terminologies. So here I list out some of the terminologies which is used to calculate the performance of the given model. So accuracy, confusion matrix, precision, recall, FN score, and how it is calculated. We are going to discuss with one example, then you clearly understand. These are the some metrics. Here I mentioned accuracy, confusion matrix, precision, recall, efforts are the sum of the performance metrics which is used to identify the performance of the classification problem. So imagine that here we are designing how to design. So confusion matrix is one of the performance metrics. So before going to design confusion matrix, what are the terms we needed to design that matrix? Let us discuss. A matrix, we are going to design a matrix with correct and incorrect predictions. So that correct and incorrect predictions will be represented by using four terminologies. True positives, here TP is true positives, FP means false positives, FN means false negatives, and TN means true negatives. So these four terminologies will be used to design a confusion matrix. Let us discuss with example how the confusion matrix will be designed. Here I take a win and loss prediction of a cricket match has two classes of interest, win and loss. For that reason it will generate 2 cross 2 confusion matrix. So let us see, we are going to design a confusion matrix for win or loss of a cricket match problem. So here this is the actual win, actual loss, here the predicted win, predicted loss. Here how the true positives, true negatives, false positives and false negatives are generated. You observed here the actual win is 85, the actual win is 85, the predicted win is also 85. So means the actual scenario is positive, my predicted scenario is also positive. Therefore that 85 I consider it as true positives. So coming to actual loss, this is negatives. These are negatives. So this value is 4. So I have to consider how many are correctly false positives. So my actual loss is 4, my predicted win it will be displayed as 4. So at that time it consider it as false positive. So false positive, actually it is loss but it's predicted as win. Therefore that the term we are going to represent as false positive. Therefore FP is equal to 4. So come to the next, actual win is 2, here the predicted loss. So here the false negatives we are going to consider is 2 and count of true negatives is equal to 9. So in this way we are going to design our confusion matrix. So actual you are going to compare with predict. If both are same, it's a true positives. If both are negative, it comes under true negatives. So true positives and true negatives. Here actually it is negative but it's predicted it as positive. That means actually it is loss but it is predicted it as win, means it comes under false positives. What's the understanding of false negative is actually it is win but it is predicted it as loss, so it's considered as false negatives. In this way we are by using these four terminologies, true positives, false positives true negatives and false negatives, we are designing the confusion matrix. So initially I tell that we have some performance matrix to calculate the evaluation of the given model. So to say that the model is best by using some metrics. So the under that first matrix we are considering is accuracy. So how you are going to calculate the accuracy na? Based on confusion matrix. In confusion matrix we calculate how many are true positives and true negatives divided by, when you are calculating the accuracy, total number of positive cases. What is this? The combination of TP plus TN means is the total number of correct predictions in it's a total number of correct predictions. TPT plus TN will represents total number of correct predictions, and total number of things, that means total number of possibilities. These are correct predictions, so total number of predictions. So TP plus FP plus FN plus TN. So what is true positives here? 85, and true negatives are 9. These 85 plus 9 is the total number of correct predictions by total number of samples. So our model will give 94% accuracy. For sensitivity, so it represents positive cases. How many number of things are positive cases? So then formula will be true positive by true positive plus false negatives. How you are going to calculate? Already we know that in confusion matrix we calculate the value of true positives, and false negatives. Then the sensitivity of the given model is 97.7. That means correctly positive cases will be predicted in this manner, in this percentage. Then total number of negative predictions. Total number of true negatives are 9. Negatives plus false positives are 4. That accuracy to identify total number of negative loss games is 69.2. So in previous win, for win the prediction, the sensitivity is 97.7. For loss 69.2. Same like that we are going to implement for precisions. Precision is also, if you observe, the precision is equal to sensitivity. Observe that there also we consider the same things, but what's the difference here? Just a minute. What's the difference between precision and sensitivity? Is in precision we consider all total number of positive cases. There total number of correct predictions of positive cases. Here total number of positives we consider. Here under recall, recall is similar to sensitivity. Correct predictions, total number of correct predictions, positive correct predictions. Don't get confused, guys. Here under precision, under recall, we consider only total number of positive predictions. That means win. Under our case study, we are considering total number of wins. Here in recall also we consider total number of wins, but in case of precisions we consider only win predictions, but in case of recalls we consider both win predictions and loss predictions. So then you calculate the precision is 95.5% and recall is 97.7%. So it's a F1 score. What is the formula for F1 score? Is 2 into precision into recall by precision plus recall. So we know the precision value of is 95 when you are going to represent it as a point, 0.95, and recall value is 0.977. These will be identified that how balancedly the model will be worked for the given input data and how accurately it will be predicted the results. So in this class I will conclude that these are all the some metrics. A lot of metrics is there: kappa values, error rate, lot of performance metrics available for calculating the performance of a machine learning model. These are all of the sum of the metrics which will be used to evaluate the performance of a machine learning model. I revise it what are the metrics. So in the starting slides these are some of the metrics. Before going to calculate accuracy, precision, recall and F1 score of the given model, you have to design a confusion matrix. That confusion matrix will consisting of 4 terminologies: true positives, true negatives, false positives, and false negatives. So at conclusion, I will make you understand. I think so. I will make you understand what are the sub metrics will be helpful to evaluate the performance of the given machine learning model. Thank you. I will meet you with some other new concept in the next video.